Stephane will be telling us about, the journey from flexible cells to flexible modules and Apollo's story for the manufacturing of record modules. We're really looking forward to your presentation.
So this talk is about our experience we had in the lab within an European project. The name is Apolo. This project ended in July. So, but we want to continue this experience with flexible perovskite. And globally, it is also the story from how to make cells, then modules with this technology. So first, rapidly, the Apollo project. The Apollo project, as I said, ended in July. So me, I'm working in CEA. So I will introduce rapidly CEA after this slide. And it was coordinated by LETAT in Spain. The end user of this project was a company in Spain. The name is FlexBrick. So the destiny of the perovskite modules was integration in building. And we did some very nice testing with these flexible modules. There are also some other partners like EPFL, Fraunhofer, Scho's laboratory also, which make also a lot of upscale regarding the fabrication of these perovskite modules. So there is a website, so don't hesitate to visit this website to know a bit more about this project, because I will show you only few results coming from this Apollo project. But first, I would like to introduce my laboratory. So I work in a CEA. So CEA, so it is written very small here. CEA, it is a French company dedicated to research. And the division related to solar application is located here in Chambéry. It is in Alps, in the French Institute for Solar Energy. The name is INES. So we have a dedicated clean room in our institute to develop perovskite technologies. So we are mostly dedicated to the development of tandem silicon perovskite with two terminals.
Hello? Hello?
I don't know if there is a laser pointer or not specifically.
You can't use the laser pointer in this, because we are showing you a slide, so you can't use the laser pointer in this way.
Okay, I can. Okay, no problem. So first, I will introduce my talk with the development of flexible cells, and then I will comment the fabrication of flexible modules in CEA. So first, about our cells. So in this project, we fabricated planar perovskite modules on cells on PET with NIP architecture. So typically, we have an N-type layer based on tin oxide. It is a liquid process. So we process this layer, which is based on nanoparticles. Then we have a double cations formulation for the perovskite, and we have all transporting layer, which is based on a semiconductor, polymer semiconductor, PTAA. And we have a counter electrode, which is evaporated, which is still gold. And then we also have implemented during this project a passivation strategy based on PAE in order to passivate the defect at the top of the perovskite layer. And thanks to this different optimization, we arrived to achieve very nice power conversion efficiency. We had to optimize the formulation of the perovskite and regarding the gap because of the use of a flexible substrate by changing typically the iode-brome ratio. But we also changed the solvent quenching process, because in this development it is still only spin coating, so we use a solvent quenching process. So here it is typically a picture of the small cells we fabricate in the lab on a flexible substrate. Something I want also to introduce, it is the importance of the encapsulation, because in this project we worked, and it was a bit the major role of CEA. It was to work about lifetime, and particularly the lifetime regarding the